All right, this is Unit 3, Lesson 4 homework, and we had a problem in class that's just like this, but it might have been difficult for children to represent, so I put one, of course, on the homework because I want them to get exposed to problems like this. Here we go. First thing I want you probably want to ask your child, what do you notice and wonder about this actual shaded area model? And ask them that and give them time to think about it. And they should be able to point out that because it's very important that they realize that on this side, these two boxes equal one whole together. Okay, so this is a whole together. So this is going to represent a half, this is going to represent a half. But you also need them to realize the most important part is that on this side it's just one whole, but right here, these three equal one whole. And this one also equals one whole. It can be a different concept. It can be kind of hard for kids to understand on first glance. So I say all that to say this: when we recognize this as a shaded area model, we need to figure out a multiplication expression representing this, okay? So the real important part is noticing that this is its own whole and this is its own whole. This is a whole and this is a whole, okay? And looking at it from this side, all of this equals one whole. I know it can seem weird, but anyway, let's address the shaded region, okay? So let's see, what do we see when we look across the top? Let's see how many of these are shaded. 1, 2, 3, 4, 5. Okay, so we know 5 are shaded, okay? But what's really important to recognize is that we're only focused on a fraction of one whole. So outside, so the craziest part about this is they're trying to, not to say trick us, but they're trying to represent it. They're introducing a way to look at it to where you're looking at two holes, but you have to recognize that you're only being concerned with how much is shaded amongst this hole right here, which can be kind of crazy because when you look, you're like, wait a minute, these 3 of this hole are shaded, but there's 2 more. So they need to be able to recognize that although it's 5 shaded, we're only worried about how much of this hole is shaded. So they have to be able to realize, and it's a weird concept, but they have to be able to realize that, oh, okay, going across, this represents 5 thirds. Because this shaded portion right here by itself, you see where my fingers are? By itself, this shaded portion is 3 thirds, which would be one of the whole. But they have to realize that since this is made up of thirds and it's breaking into that next hole, is actually taking up that. Because if all of this were shaded upon this top row, it would be considered 6 thirds, because this top row is in thirds of a whole, okay? So we need to recognize that and notice that this is going to represent 5 thirds. And what does this represent? The shaded portion is representing 1/2 of this whole, correct? So what you want to see is you got 5 thirds going across here. And I know I'm being drawn out, but I'm trying to get your kids to really look and analyze why this represents 5 thirds. Because going across, it will represent 3 thirds. But we're talking about 5 thirds. Okay, so 5 thirds times, what does this represent? 1 of the 2 on this side. So it's going to be 1/2, because when you look at it here, this is just 1/2 shaded of this whole. Okay, so now kids need to recognize, now we got 5 thirds times 1/2, or 5 thirds of 1/2. All right, and now we're ready to go ahead and multiply. 5 times 1 is 5, and 3 times 2 is 6. And it makes sense because look, our answer was 5/6. So let's look at this hole. How many sixths would you get in this hole? And your children should be like 1, 2, 3, 4, 5, 6. Oh, there's 6 sixths in that hole. So now you see this shaded. You got 1, 2, 3 of those sixths is shaded. So that 3/6 of that hole is represented here. And then look, oh, there's 2 more. That's where if you combine these two, imagine that we move these two over into this area, because that's really what we're doing. Let's go ahead and take it in as if it was written without that. Let's say, okay, our answer, all we did was with our answer, we took those 2 that were extending into that one, and we moved them down here. And what did we get? Now 5 of these sixths are shaded. Okay, so that's what you want to do for that problem. And it's kind of a tough concept to introduce, I'm not gonna lie, because it's like, it's interesting because they want you to look at it this way, and the model, it gets kind of tricky when you got a hole here and then it extends into a second hole. So that's why it's an improper fraction when you look at it from just this aspect. All right, so our expression, because I want you to write the expression and find the area. Our expression would be 5/3. The 5 was represented up here. 5 of the whole is in thirds, and there's too many of them for that. So it's 5/3 times the 1/2, which is now 5/6. Whew, sorry. Let's go to the next problem. Okay, a field is in the shape of a rectangle. The length of the field is 3/4. The length of the field, the length of the field is 3/4 mile long. The width of the field is 1/3 mile long. So I would like for you to draw a shaded area model representing this problem. That's the first thing I want you to do. So your child should know, get used to drawing rectangles. We're drawing a lot of rectangles. All right, so now let's represent the length of the field. The length of the field would be 3. Well, first ask your child what's the important information in this problem. They should be able to tell you the length is this, the width is this. We know area equals length times width. Boom. Now they should be ready to solve. All right, and we got, let's represent the length first. The length is 3/4. So I'm going to break it down. They should know by now. I'm going to break it down into fourths, just like Mr. Oliver said in class. We could break it down into fourths. Now, let's represent 3/4. So let's go ahead and shade it. Let's shade 3 of them. All right, I'm going to lightly shade it with red. 1, 2, 3. 1, 2, 3. Okay. And I want to get a different color marker. I'm going to use a different color marker, hopefully to make it pop a little more. So we got 3/4. That's our 3/4, the length. I'll go ahead and write, let's write the length and what it is. 3/4. And the width is 1/3. So your child at this point should be like, oh man, how do I represent 1/3? I could do it with some opposing lines, some lines that are perpendicular to these, and we could be like, I'll just separate it into thirds. Okay? Now I want to represent the width of the field. I'm going to do that with a different color, and we want to represent the width with 1/3. So now that I've broken it up into thirds, these are the 3. Let's go ahead and shade in an entire row because we want one of those. Okay, so I'm going to shade in with green. And now, by this time, your child should know, hey, wait, there's one area that's double shaded. What area is double shaded? That double shaded area should be our answer. Okay, and our answer, I look and I'd be like, well, wait, these are double shaded. So I'd be like, 1, 2, 3. So I know that I got, it would be a 3 out of what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3/12 should be my answer. And I would like for them to be able to simplify this fraction. And when I say simplify, I think I'll go into that right after. But I'm okay with right now, just leave it at 3/12 because we did 3/4. We did that. And then we did 1/3. And what happens is we showed our area model and showed this 3/4 times 1/3, and it should equal 3/12. And now, just real quick, just like our last problem, we have, I would like for you to write and solve a multiplication expression answering this. So let's go ahead and do it. We got our length, 3/4 times 1/3, and we know, let's multiply straight across and see if we get the same thing. 3 times 1 is 3. 4 times 3 is 12. Our answer is 3/12 miles. Okay? And I would also like to show your children how, because our answer is 3/12, and I like for them to take the further step to go ahead and what we call simplify 3/12. Okay? Because 3/12, you want to find out, man, is there a way that we could simplify 3/12? What you want to ask yourself, is there a number that I could divide into both of these numbers, and that will divide evenly into both of these numbers? Let's think about it. You could look at 3 and 12. You could think about what are the factors of 3 and 12? Well, I know that, let's see. Let's go ahead and write the factors of both. 3 and 12 right here. I know the factors of 3 are 1 times 3. So it's 1 times 3. So there's only 2 factors of 3. And those are 1 and 3. What else can we do for 12? Well, we got 1 and 12. Both of those. And then we got 2 and 6, because 2 times 6 equals 12. And we also get 3 and 4. So now you want to look, do they share any common factors? Maybe we could circle the common factors that they get and think if we could divide one of those into both of them, and maybe that'll help us simplify the fraction. So they should recognize that they both share 1 and they both share 3. So let's take that bigger number and see what happens when we divide that bigger number into both of these. So let's do 3/12 divided by 3 on the top and 3 on the bottom. 3 divided by 3 equals 1, and 12 divided by 3 equals 4. So that's going to be the process that you want to do when you want to further simplify or see if it's possible to simplify whatever fraction that you're dealing with. And in this case, this one could be simplified because we found a common factor that we could divide into both of them, which in this case was 3. All right. Thank you. So your answer, I'd actually be okay if your answer was 3/12, but let's say it's a test and they want the answer in the simplest form. I would like to see 3/12, and 1/4 is in the simplest form. All right.